time of the car. So this means quality, and this also has to be assured by software and by electronics. I told you there is a lot of software inside the car, which is 1 gigabyte, and more than, as we have seen, more than 70 to 90 control units. And the question is, how do we handle this? How do we keep the system handleable? And the idea is to structure it in small parts like subdomains. Inside the car we have a couple of domains. First of all, we have the powertrain domain, which is everything about the combustion engine, the clutch, the transmission. And we have the chassis, which is everything about braking, steering, and the wheels, with also together with the axles and suspension. We have the body domain, which means everything which is related to the outside part of the car, and some other aspects like climate control. We have the power window. We have the mirror control, which means adjustable exterior mirrors. We have lights, exterior light, interior lights. And this is more or less the biggest domain. And we have the infotainment, which is radio, everything with information and entertainment. So infotainment, which is radio, navigation, traffic information on the traffic situation, and things like that. And we have the driver system, which Markus already mentioned is one of the biggest growing part inside the car. So right now we have lane departure warning systems, we have park maneuver assistance, which is a system which helps you parking or even does it automatically for you. And there are a lot of more things imaginable, like in the end that the car drives without your need or without your without needing that you steer or using the pedals, so it drives autonomously. So this is the driver assistance domain, and with each domain you have a couple of control units which are part of this subdomain, and these subdomains are or these control units communicate via one bus system. So, closer look what means powertrain, so that you can imagine where it is. This is a schematic picture of an X5 seen from above, from below. So we see, of course, the engine, which can be seen here. We see the gear, the transmission, and the clutch. So which is for in the transmission. We see the drive shaft, and in some cases also the axle is part of the powertrain subdomain. So these are the main components, and nearly every part of the powertrain domain is controlled by some electronics and a lot of software. So of course the engine control unit, we have transmission control unit, and in some cases we have also automatic clutch systems and things like that. So having a look at the chassis, we have here the suspension, which is responsible for the comfort, driving comfort. We have the steering. Of course, you want to turn around the bend. We have wheels. With the wheels, I'm always a little bit fascinated, because what would you guess? How much is the area between the car and the street? How much in square centimeter? Any idea? So how big is the contact area between the car and the street? So it's it's about 10 square centimeters. Yeah? So, and this is responsible for all what you are doing, that your car keeping grip on the street, even if you drive, let's say, 150 miles per hour. Yeah? So it's an amazing fact what wheels have to perform. Yeah, we have damper also for comfort, and we have the brakes, of course. And finally, there is the axle, which is typically part of the chassis domain. Yeah, let's have a look at the driver assistance system, which is probably the most interesting part for software engineers. This is a picture of the head-up display in the BMW cars, which shows all the information which are projected into the windshield. Yeah, so you can see it near the steering wheel, and you don't have to look to some display on the side. And these are all parts of the driver assistance system domain. So we have the traffic sign recognition, which shows you what kind of traffic signs have been next to the street. This is done by an image processing system. We also have the speed limit info, also done by image processing system, all done with software. We have a lane departure warning showing that there are here two, so the yellow triangles show that there are two lines recognized to the left and to the right, and the car will inform you when you leave or you get too close to one of those lane lines. And we have the cruise control, which keeps the speed with respect to a car in front of you, and here it's shown that there is a car recognized. This system works in some cases via image processing, so there is a camera which recognizes by pattern recognition there is a car in front of us, and in some cases it's a radar system, which is quite simple but much more expensive. So the future system will work on camera system, while camera system have the problem or the issue with rain and dirt on the windshield and things like that. Yeah, and on the right hand side you see navigation information, so which way to go. Yeah, another driver assistance system is the rear view camera. There's a camera in a lot of cars at the back end side, which shows or helps you to get into a parking lot backwards. And you can see the lines which show you the maximum angle you can drive, the red ones. And another one is a surround camera, which there are some camera which show you the area around your car, so that you don't oversee any small things on the floor, yeah, whatever it is, called the surround view. So these are the driver assistance systems. And we have the infotainment system, instrument panel, display navigation, radio, CD player, and similar things. And also the user interface, which is kind of, here we see the BMW iDrive, which is a knob which can be used to select things on the display, like I would say a mouse for the car. Yeah, so main systems, I forgot one domain, the body domain. So too much things to show in one small picture, so I step rather to textual representation. So we have the access system, the locks and things like that. We have the central locking remote, anti-theft system. We have window lifter, sunroof, convertible control. We have wiper washer, rain sensor, exterior mirror control, seat adjustment, seat adjustment, steering wheel adjustment, heating, climate. We have internal and external light. and we have airport control and restraint systems, roll bars which are responsible. So if you're driving in a convertible and your car is turning because you have been driving too fast to a bend, then there is other roll bars which protect you from being hit on the ground. So let's go to the next step, which is the function development. Patrick, please, so your main topic.
Thank you. So you have quite good overview what is on the top level, on the system level, the functionality of a car. Now, for you, it's, I think, quite interesting. How do you get this functionality to real life? So how do we get from this idea of we want some camera system, or we want, in our case, how we want to get from the idea for an electric car to a real functionality, a software you can use, and that the car is really running on some software and hardware. So that you get some impression what is function development about. It's more or less a functionality, a feature, first of all. So we are talking about customer demands, like preparing the drive. You want to do something with a BMW remote app to start charging, something like that. You want some different behavior of the car. I mean, unfortunately, we have not so many electric cars on the streets right now. But if you try to drive it, it's a bit different to a normal car, because you don't have the clutch, but you have more or less just the braking pedal and gas pedals to give to require torque. And what we did is we used the have on the electric drive that you can put back energy into the battery, that we changed the behavior of the pedal. So more or less you can drive in the city nearly with one pedal. So it's like pushing on the pedal, you just start driving, and if you want to brake, you get back with the pedal, and the car slows down, and all the energy on this one pedal is really in the feedback to the battery. So if you want to brake hard and really have a sort of emergency stop, you need to hit the braking pedal, so you have two pedals. But normally, if you drive normally in the streets, you have this new feeling, and that's really great, because it's a completely new feature, and if you get used to it after 10 minutes, and after this you want it all the time. It's really a nice driving feeling. Yeah, and then that's more on the customer side, but if you think about all the new components within an electric car, you need to manage those. So like battery, you need some high voltage battery management, you need some e-machine control, so that's more or less the functionality we are talking about. And if you now want to implement some software, you have to go down to software functions, and that's exactly the process I want to describe to you in the next minutes. Yeah, so first of all, as Peter already said, we have quite a complex system. So we have to find a way to organize our work and to more or less structure the systems into part system. We already talked about the domains, but even within the domain, you have a lot of functionality. And that's exactly the idea of the V model, that you more or less describe the development life cycle of a product. So you start with the system, like we already have seen. You do some requirement analysis. So what is the functionality we want to have? What is more or less the things which need to be implemented? The more or less the output of this process is a specification of the logical architecture. So more or less you have some major view on the system you want to develop. Next step is designing of the technical architecture. So it's if you say we want to charge, it's quite complex and abstract. So at the end you need some charging plug, so there's some thing where you can plug in your charger. You need some wire harness between the charger plug and the battery and so on. So that's more or less the technical architecture you want to define. Yeah, and output is more or less hardware and software requirements on those system parts. And now we come down to the component. So we need to design the real architecture within the component and what's the functionality of a component. Output here is, once again, we're doing a lot of specification work, specification of software and / hardware components. And at the last step, you know what you want to do within the component. You can start developing of the software components. And then that's exactly why it's called recycle. We go back up again. After you did this, you want to make sure that quality is right. You met all the requirements you wanted and so on. So you start testing. So you go through the complete tree, like, oops, wrong direction. You do a module test to check if you did the right on the software components. You do a software integration test on the component level. Output here is a software integration test report. You go back and check the design of your architecture, and you get some system integration test. And at the end, you want to see if the customer requirements are fulfilled. You are doing an acceptance test and do a report on this. So that's more or less the general development cycle for functions and the hardware and software about this. And now, sorry for the small format, but now I want to go in more detail. So really, the steps I described in a brief overview, how do we really work on those topics, and how do we get a complex device into more single ones? So first of all, we think in a more abstract way. So we have some features we want to implement, and at the end we say we have a function list where we just write down what is the functionality we want to have. That's the white area on the top. Then we more or less break this down into more separate draft functions, where we have an abstract description about what should be part of this functionality. And then we go down, we structure this once again, describe the connection between the functionality within a function net. Now we come to the software area. This was until now more or less abstract view on the functionality. Now we do the partitioning of software components. So we describe in a software net how the software components talk to each other in interfaces. And at the end, you need a board net that all the components can communicate with each other. Okay, now what is the requirement? First of all, as said, we have some functional requirements. So functional requirements is everything really where we have a direct function behind. Let's say we want to charge. So that's really a requirement. Provide a system that can charge at with some voltage, with some special charging plug. For those requirements, you need complete, consistent, clear, and measurable requirements. That's quite important, that you at the end can test also your requirements. So that's really important to consider and think about those things at the beginning of a development. If you don't do it, at the end you don't know where to test and what's the goal of your development, and then the things get blurry, and probably you don't get the best product you want, because the communication to colleagues is quite hard and nobody knows what was the real goal of the thing. So you need really, I want to build a car which can drive 250 kilometers. That's so maximum speed is 250. That's the exact requirement. If you just say, okay, I want to build a car which can drive faster than 200, okay, that's the requirement, but do you expect 250? Do you expect 300 or whatever? you don't know. And so the colleagues doing the tires, they don't know exactly which rubber and so on. So if you don't describe your requirements in precise and measurable, you will have a problem at the end in the development. But then, as Peter already gave a short brief view on this, you have a lot of non-functional requirements, like product topics like usability, efficiency, because at the end you want to put the functionality on some ECU, some electronic component, and it needs to run. So we don't want any blue screen that your braking system won't work. So it's really important that you have the performance, reliability, portability for reuse of components. Then for enterprise use reasons, more or less, you want to bring this really into the market. So we need some methods and we have some requirements how delivery, implementation process is going on, so that we really can make sure that we deliver the product on time with the right tools. We don't need to do some extra mile for every component. So that's quite important that you have rules how the functionality is implemented within the project. And of course, we have external requirements like compatibility. This can be standards. This can be legal things. We have ethical requirements, data privacy. Probably if you want to use your mobile phone within the car, you don't want anybody else to listen and so on. So important things that your data is not shared with others. Security and of course, quite important and really important, safety. And then last one, domain requirements. That's mainly how to integrate the functionality within the domain, like body electronics or power train. Okay, now we talked a lot about requirements. How do we identify requirements? So how can we make sure that we have a process to really identify the right requirements and that we don't lose anything? So we have a procedure that we more or less start to identify the stakeholders. That's mainly, of course, the driver or the customer. But we have also some production employee and we have some service employee. So at the end, you have the customer, but you also want, if your car is at the service, that you have a proper service, and the service colleague can do a fast and efficient service on the car. Now, you think about the use cases which each stakeholder has to do. So mainly the driver, for example, in a charging for electric car, he wants to stop charging, start charging. If he has some app in his phone, he probably wants to start remotely the charging or stop charging. You could have some timer-based charging and so on. So you just think about all the use cases. And if you think about the production employee, he needs to initialize the car that more or less you get a good working car. Then service employees need to diagnose the car. Next step is to relate each of the stakeholder with the use cases you have. So that's quite easy. Next one, the use case itself have sub-stages. So more or less, you say, okay, some stop charging within the app is the same like if the customer stops charging and so on. So you do the relation between the functionality. Then, quite important, what are the system boundaries? That where does it stop and what is not handled within the function the requirements? and so you make a sort of box out around the functionality. Now, I think those things probably you had already in courses, and what is quite interesting is safety issues. How do you include now to these quite straightforward? Everybody who can think more or less comes to this conclusion to do it, but how do you include now safety requirements? And this is quite easy, but you have to consider it. So first of all, what is safety about? Every technical system can fail. So it's just a matter of amount of components and time you use it. At some point, you will have a failure. So you can be sure that you have no safe execution of safety-related systems because it can fail. So what you need to do is you need to have some reaction if a failure happens. Next one is safety logic needs to be specified. So more or less out of this, you need to have some specified safety logic. And the second thing is probably you cannot detect some hazardous situations. So at the end you need monitoring also to identify exactly those unwanted or illegal system states. Meaning, if we come to the requirements, because that's exactly what we do now, like the customer requirements, we say, okay, you have to identify functions that have to be monitored. You need to identify the defects, and you need measures have to be taken. Okay. So now we have a lot of requirements. The question is, how do we get those requirements now to some software components? What's the process to get there, so that we have an idea where to write the right software, what interfaces do we have? So more or less, you think now in this way that you have clusters like you have an instrument panel on the information technology side. You have some fuel sensor or battery level voltage, some sensor. At any point you want to show information out of this. So you have, for example, a fuel display. You have a velocity display. You have some travel information. You want to show. That's all you get out of requirements, more or less. You say, okay, I want to show this and that. Now you consider the sensors and which interfaces you need. So you have to transfer the information of the fuel sensor. You need to transfer some velocity of the vehicle. And as output, probably you want to give some information about the range which is left in the car. So you combine your functionality with the interfaces and information and have input and output, and that's more or less the abstract definition of your software components. Now you have a sort of description of your software components, and you want some control loop. For example, in the BMW i3, you have the e-machine you want to control. So more or less, you have the driver, you have a set point device, which would be the gas pedal. Now out of the angle of the gas pedal, you know how fast or how much torque the driver wants to have. So more or less, this is the set point device, which gives the set point, that's the torque request, to the control algorithm. The controller itself needs to check what's the current torque we have and what's the torque we need to bring into the system, and you have some output of this controller giving to the actuator, which is the e-machine, the new feedback, and you have the control system at the end, which is more or less the car with the speed. Now, to check if everything is right and to have the feedback, you need some sensor information, of course. So like speed of the machine, the current flowing through the e-machine and so on. So that's mainly the typical control loop.